All right, welcome everybody. Thank you so much for being here. Happy SoSTEM. Woo! We are so excited that you are here today and that you and your fearless teachers have braved the snow in DC, which is always a struggle, I know. But we are so excited to talk to you all about the amazing things that we're doing with science and technology and different careers that you can find in science and tech and just all of the opportunities that there are. And we're also very excited to have this event as part of our Big Block of Cheese Day, which is something that President Andrew Jackson did. And he brought in a giant slab of cheese to the White House and invited people to come on and eat it. And just talk about policy, ask their questions. So we are doing a digital Big Block of Cheese Day. We don't have any actual cheese here. Sorry about that. I know. But we are inviting everyone who's tuning into our live stream on whitehouse.gov/live and on NASA TV to ask their questions with the hashtag SoSTEM, which is right up on our screen right here, and also hashtag #@the-White-House. So we have some incredible speakers here for you today. You'll be hearing from some folks in the Office of Science and Technology Policy, where I work. We also are so lucky to have Administrator of NASA, Charlie Bolden, here today. And I hope you all have your questions ready for him and some special guests. And then we also have an all-star panel of awesome women in STEM from both the federal government and outside that we hope you're all excited to ask questions. So I want to kick things off by inviting our Chief Technology Officer, Megan Smith, up to the stage. She came to the White House a few months ago from Google, where she helped create things like Google Earth. And so she is an awesome, awesome person to be an advocate for tech in our administration. We're so excited to have her. So without further ado, Megan Smith.
Yay. Science and technology in the house. Welcome, you guys. So I just got to talk to all these cool kid reporters. Do any of you guys read Time for Kids or National Geo? Yeah, lots of readers. Or you read it when you were a little bit younger, because we've got some older kids here too, who are now reading Time Magazine and National Geographic. But these guys are doing stories today, so I encourage everyone to talk to them. It was fun to talk to them, and one of the things they were asking me is, well, how did you end up doing this? You know, why did you end up becoming an engineer, and what happened in your life? And it kind of connects to the White House, because when I was little, we had a big energy crisis in the US, and Jimmy Carter was president. And so he started to bring a lot of leadership around thinking about, in addition to oil and gas, could we get to green technologies that would be so great for our environment and also would take us off our dependence on oil over time, which was very expensive and continues to be a challenge for us sometimes. And so he started putting solar collectors on the White House as an example of something he could do. And so I got interested in those areas, and we were lucky. I grew up in Buffalo, so I'm very happy it's snowing because I love snow. I grew up in Buffalo, New York, and there were a lot of different opportunities, but in our school it was mandatory to do science fair. And so I was lucky, because in addition to hearing about science, our teachers, like many of your teachers, would make us actually try it or do it. And so I got to work on solar collectors that I worked on designing and playing with. I made a windmill one time, worked on hydrogen power and other projects. And the main thing I was talking to you guys about, and I think is really important for everybody to realize, I mean, who here knows how to read, right? And who here knows how to write? Okay, so did you know how to write right away? Or did you kind of start hearing about these letters and then writing them out, right? The same thing's true in science and technology and engineering. It's not like everybody shows up and can do perfect projects. You start with forming the letters. And that's true both for learning, but also when you begin a project. So everything from the amazing team from NASA is here. And look at the incredible things they're doing. They didn't start, we started, for example, when we first started getting off the planet, with small rockets and really early ideas and prototypes and playing with that and getting really different cross-functional teams who thought differently to work together. So just always remember, you got to start somewhere. And just like as humans, we crawl, then we walk, then we run, that's the same thing for learning science and technology. The president last night talked a lot about how we're doing as a country. And one of the things that was exciting to see is that we're at an all-time high on sort of our science and math scores. And so you guys are really getting it done, so thank you for that work and keep working hard. You know, science and math is not easy. It takes a lot of grit, but it's really fun, and you can do extraordinary things with it. And you guys are going to hear a panel from people who are using coding to help veterans. People are doing things in space. People are doing things with our environment and our parks. People are working, also veterans, and amazing work in climate. Nicole's work, Nicole was in the president's box or the First Lady's box last night, and is working on sea level rise. We have a lot of work to do on climate change and climate, and so the scientists and things that you can use technology and code and science for are right there. One of the things that sometimes happens is we got mixed up ideas about who does this work. So have you ever watched TV and you're watching the show and the computer science person is always somebody who's not of color, somebody who's always a boy? Did you ever notice that on TV? So sometimes that's like bias that goes on, or somebody might think that just boys do something, or just one group or one race isn't. That's not true, and it's never been true for all of history. One of my favorite things is in computer science. I got to work at Google, and one time we went to visit England, and we saw this beautiful portrait, and they said, of course you guys know who this is. This is Lady Ada Lovelace. And I said, I have no idea who that is. And it turned out that she worked with this great guy, Charles Babbage, in the mid-1800s. And he got this idea of a mechanical computer, one of the first computers, a mechanical calculating kind of machine in the beginning of what is now, you know, your iPhone or your Android device or your mobile phone. He got that idea, and she got an idea that in addition to what he was doing mechanically, you could maybe program it or write algorithms, what is now computer science. And so there were women and men working together from the very beginning of all of this stuff. Just sometimes it doesn't make it into the movies or into TV, but we're working on that. So the other thing I wanted to encourage you guys to do is to, in addition to trying it, one of the things that we did with the president we were lucky to do was he came into something called Hour of Code. Did anybody in this room do Hour of Code? Yeah, so a bunch of people. What did you guys do? You went what? You went on a computer. You practiced writing code. And what was it like? Was it hard or easy? In the middle. Cool. Yeah.
We did this website called
Code.org, right.
At first it was like we had to do an Angry Bird.
So Angry Birds and...
We were telling everyone to go forward and then left and then right to get to the pig.
Yep, exactly. So you were saying like the bird was moving forward, and what were you going to say? Yeah.
So I was just going to say that it would get harder each time. So I agree that it was kind of in the middle.
In the middle.
But it was really fun.
And did you do things with Angry Birds or do you do things with other characters?
Yes, but also recently there's this website where you can code like whenever you want. It's like Lightbot.
Lightbot? Yeah, there's a lot of cool things on the internet that if you work with your teachers and that. So my main thing to you is the same thing with code.org. You want to, and these other sites, just go there and try them. And what you found out, code is just a list of instructions, right? Is that right? So I encourage you guys to get out there, do science. You got some amazing heroes. Some of my heroes are here today. And so I'm going to invite our leader of NASA. We're here with the Chief Scientist and our overall Administrator for NASA. So Charlie, please come and welcome to the world.
All right, my part is really quick. So I'm supposed to welcome everybody and tell you what we're going to do today. We're going to give everybody an opportunity, well, not everybody. We're going to give several of you an opportunity to talk with the International Space Station. And we've got Butch Wilmore and Terry Virts, I think, are going to be there when they come on the screen. So my job is to encourage you to really, if you're not already doing it, really get interested in science, technology, engineering, and math. We had 4 incredible reporters that we were privileged to talk to beforehand. And I want all of you, whether you're in high school or elementary school or whatever it is, to try to get fired up today. Okay, you know, the president talked last night about Orion and its success right at the end of last year. He talked about the fact that we're trying to get people to Mars in the next 20 years or so. And we need mostly this group over here. You guys are getting kind of old. But we can, there's still hope over there. But mainly this group, because you're the ones that we want to get to Mars. So what we're going to do, when they say come up, you're going to come right up here, and I'm going to meet you out here in front of the podium, and somebody will give you a mic. We want you to tell them who you are, what school you go to, and then your question. And you can ask, they're telling me we got 2 minutes, so I got to get fast. You can ask one or the other. They're Terry and Butch. Those are the names they go by. And you'll figure out who they are because they're going to come bouncing out, and they'll introduce them, well, kind of, and they'll introduce themselves to you. So any questions about what we're going to do? Any questions about science, technology, engineering, or math? Who's going to Mars? Yes. Go ahead. Go ahead. Where's my mic? Go ahead.
What are you most excited about NASA doing?
Oh, I'm excited about everything we do, but the most, I always get in trouble as the NASA administrator when you say there is a most exciting thing. Let me say this. The most exciting thing that we get to do, because they let me do it, is come out and work with students like you. That is the absolute coolest thing in the world, to get an opportunity to go to schools and meet with some of you and come and do things like that. That's really, really cool. But we do a lot of stuff in science, aeronautics, human exploration, technology development. We'll talk a little bit more about it. Question back there. They're going to tell me we got 30 seconds.
What's your inspiration?
My dad. Come on. I grew up in Columbia, South Carolina. My father was an incredible father, but my father was also my high school football coach. And so I was blessed to have the same person be 2 heroes for me, and he was awesome. He was really tough, but incredibly fair. And my inspirations today are my son and daughter. I have a son who's a colonel in the Marine Corps, a daughter who works not very far from the young men back there from Cardoza. She's a plastic surgeon at Howard University Hospital, and so they inspire me every day, and I try to tell them that. And I also have 3 beautiful granddaughters. So I'm surrounded by women in my life, so women in STEM. And the oldest one is a freshman at McLean High School, and she wants to be a rocket scientist. So what else can I tell you? Yes. 1 minute. I got it.
Out of all your accomplishments, which one do you think is the most important or the biggest?
I took part in this, okay? I didn't do the work, but my son and daughter are my most, they are my crowning achievements. My wife did all the work, but I participated. And that's all I'm going to say. Yes,
Okay, it's working.
right there. Go ahead, and you can yell it. I'll repeat it.
What motivates you when things go wrong?
What motivates me when things go wrong? And things go wrong a lot. And I think it's really important for things to go wrong and for you to learn how to deal with them. What motivates me is the knowledge that we can make it right.
We are absolutely ready for the event.
Just because something happened, and sometimes bad things happen.
This is Mission
Okay?
Control.
All right, all right.
Please call the station for a voice check.
Hey, Houston, this is Charlie Bolden. How do you read? Houston, this is Charlie Bolden. How do you read?
Clear. Welcome aboard the International Space Station.
Hey, Butch, how you doing?
We're doing great, sir. How about y'all?
Okay, I'm glad we didn't go through all the protocols and everything, but what I'm going to ask you to do, Butch, is introduce yourself and the rest of your crew members there. Samantha, it's great to see you. This is the first time I've had a chance to talk to you. We have a group of school students down here from elementary all the way up through high school. Any college students? No. And they really are anxious to ask you some questions, so I'm going to turn it over to you to introduce yourself and your crew, and then we'll get right into the questions, if that's okay with you. And tell us a little bit about what's going on today.
Outstanding, General. Yeah, absolutely. I'm Navy Captain Barry Wilmore, call sign Butch. That's why he keeps calling me Butch. And I've been up here for 4 months. I launched on a Soyuz 40S. and was joined by these folks right here a couple of months ago. I'm going to let her introduce themselves.
I'm Air Force Colonel Terry Virts, and I launched in November with Samantha on Soyuz 41S from Baikonur in Kazakhstan. We've been here for about 2 months, and we've been very busy doing a lot of experiments and science, and also getting maintenance done, keeping the space station in working order.
And I'm Italian Air Force Captain Samantha Cristoforetti, and of course I came here about 2 months ago with Terry, and same as Terry, I'm enjoying my time up here, doing a lot of science, doing all kinds of interesting scientific research, and enjoying floating a lot.
Great. Well, Terry, Butch, Samantha, I'm now going to turn it over to the
somebody's got a
students.
question.
We do, and here they come. And you can step right out here. They can't see you.
My name is Latrice, and life in space hard or is it easy?
Is life in space hard or is it easy? Well, it depends on what you're doing. Some things are, I would say nothing's hard. We're very, very well trained, prepared well for all different aspects, the launching, the different science and protocols and things that we do, maintenance that we do on board station, of course the re-entry as well. When we come back on the Russian Soyuz, we're very, very well trained, but days are long, and sometimes they're filled with many different tasks. So if anything hard about it, that would be it. Just keeping mentally tied in all the time can be very trying on your mind. But what a great environment. What a great place to work. I mean, you can flip upside down in a heartbeat. The floor is the ceiling is the floor. There is no up or down. And like Samantha said when we started, it is a fabulous time, and it's a lot of fun.
Thank you.
My name is Connie, and I go to Murray Elementary. What is your favorite thing in space?
That's a great question, and as you can see, it's so cool floating. You can go on the ceiling, you can go on the walls. It doesn't matter which direction you are. You can just readapt. And after you've been here for a few weeks, you really get used to floating and being weightless. And it's really fun to be able to move around and just kind of, with no effort, flip yourself over like that. And for me, that's probably my favorite thing that we get to do up here.
Hello, I'm Carrie Mullins. What did you have to do to become an astronaut?
Well, there's different paths to become an astronaut. Some astronauts are military pilots. Most of them are also test pilots. Some astronauts are scientists or engineers, and a lot of astronauts have mixed backgrounds, like they are pilots, but they also have a background in science or engineering. Or medicine. You can also study medicine. We have also doctors among our fellow astronauts. So those are main paths. It's important, to work hard in school, to do well. And I like to say it's really important to choose a career, before you become an astronaut that you really love, that you're passionate about, because that's really the key, the secret to being good at what you do. And, when you're good at what you do, then you're also a good candidate for the astronaut program.
Hi, I'm Danny Michaels, and I go to Maury Elementary. Mine's kind of similar to her question. What pushed you all to be astronauts? And how's the weather up there?
Danny, the weather is always clear, so that's a good thing. What pushed me to be an astronaut? I think the biggest desire I had was to do the best with what the attributes that the good Lord gave me, and to try to pursue any and everything that I could. And I wound up joining the military, had a patriotic tug, and as I was in the military, was able to fly, had that opportunity, went to flight school, and once I got my wings of gold, my Navy wings of gold, there was no higher place you could fly or faster to fly than on the space shuttle. So that set that as a goal out there, and thought maybe one day that might be an opportunity. And eventually in 2009, I was able to do that, fly the space shuttle, and then recently, like we just said, 4 months ago, launched on a Russian Soyuz, and here we are now. So I'm very grateful for all the opportunities. It's certainly not ourselves, it's many people involved that actually get us to this point. So grateful to my family and all of them as well.
Thanks a lot.
Hello, my name is Charlotte Basso, and I go to Watkins Elementary. I was just wondering, how do you move around in an anti-gravity environment?
Hi, Charlotte. Like we were demonstrating before, that is something that you kind of need to learn how to do, and you have to learn quick, because as soon as the rocket's engines shut down a few minutes after launch, you're weightless, and you don't have time to learn how to walk. You just have to do it. But it takes a little bit of getting used to, but we've been here for long enough that we know how to move. You have to move very slowly at first, and if you push just with a little bit of force, I don't know if you can see my finger here, but I'll push on Samantha's shoulders, and you start moving. So you have to control how much pushing and pulling you do, otherwise you'll go flying into the wall and hit your head on something. So you got to be careful, but it's really fun, and it's something that the humans can really learn how to do and adapt to. Hey, I have a question for you guys. Anybody go to Maryland schools there? I grew up in Maryland. I went to school in Prince George's County and Columbia, Howard County.
You got a bunch of hands going up there, Terry. What school?
I hear some clapping.
Oh, you're going to ask a question. Go ahead.
Hello, I'm Labrea from Western
I went to Fort McHenry Elementary. I asked a question. I went to Fort McHenry Elementary in Lanham and Oakland Mills and Columbia. But I'll let these kids ask some questions. They're more important than mine.
Okay. Hello, my name's Labrea. I go to Western High School. My question to y'all is, I heard that y'all 3D printed a tool. How is that going? Did you use it yet?
Yes, we did. We had several things that we printed a 3D printer. The 3D printer has now been stashed away, and all of those items that we printed have been bagged up because we're returning them to Earth. They're going to be analyzed, because before they sent that printer up here, they actually printed the same items on Earth that we printed up here, except for one. We printed also a ratchet wrench, and but all those things are going back. I wish I could show them to you. That's not what we printed.
I know, but it's a real one.
Yeah, but yeah, the ratchet wrench we printed was similar to this one, just fairly small, but a ratchet wrench, and it was actually usable. You could actually use it. They wouldn't let us use it. I wanted to, but anyway, those are bagged up and be heading back on the SpaceX, the Dragon capsule that'll be heading back, I think, around the 10th of February. So that's what those are now.
Hi, my name is Robert Golan, and I want to know, how is it like being in a spacesuit when you're outside of your ship or aircraft?
Robert, that is a great question. What's it like being in a spacesuit when you're outside of the ship? You know, Robert, when you get in one of those spacewalking suits, you actually get into a spaceship. It's a one-man spaceship. It's got all the life support. It's got the oxygen that you need. It's got cooling system that circulates cold water so you can stay cool, so you don't get overheated. The only thing it doesn't have inside is food. You can have we have a little water bag, but we don't have any way to take food with us. So we can only stay for certain lengths of time. But it's absolutely fascinating. The view through the visor without having an atmosphere to look through, just the vacuum of space, is so clear. And it's just the thought that when you're outside, we never go out alone. We always send two people out. But you think about it, you're the only two people in the entire universe that are doing something like that at that moment. It's a pretty special thing.
Hi, I'm Nandini from the Thomas Jefferson High School, and I was wondering, before you first went out into space, what was the thing that intimidated you the most, and how did you overcome that fear?
Well, I can tell you that the day that I went on the spacewalk, I don't know that there was a lot of fear, but even more so, there was a spacewalk by my two comrades, Commander Wiseman, also a Navy commander, and Alex Gerst. They went out on a spacewalk about 9 days before Wiseman and myself went out. And when I suited them up and got them ready, that was the most stressful thing that I have done up here, because their lives were literally in my hands. I had to get their helmets on right. I had to get their maneuvering packs on right. I had to make sure that the depress of the cabin went just according to plan. And that was actually much, much more of a stress, because it wasn't my life that was at stake. It was theirs. And that's something that's a very, very detailed process, getting someone out the door. You know, you think when you open the hatch the first time and you go outside, you've already been in the suit for 5 hours, almost 5 hours, even before you open the hatch. And the person that's doing the most work is the one that's getting you ready to go out. And the next spacewalk, if it goes as planned, Colonel Wirtz and I are going to go out, and Samantha's going to have that task. And I tell you what, I don't envy her, because it is a very detailed, very important, vitally important thing to do.
Hello, I'm Kelton, and what was this a job you wanted ever since you were a kid, or as you got older, was this something you wanted to do?
I didn't understand.
Hey, that's a great question, thanks. Actually, when I was very young in elementary school still, I don't think I was 8 years old yet, I already told people, adults and teachers, that when I grew up I wanted to go to space. And of course I didn't have an exact idea of what it means to be an astronaut back then, but as I grew up and I had a better idea, this thought of becoming an astronaut and going to space actually attracted me more and more. And then I was fortunate enough that growing up I developed mature interests for science and technology and for flying. And guess what? Those are the things that can lead you to becoming an astronaut. So it all came together wonderfully for me. And you know, it's just the best thing that I could possibly imagine doing. So I'm very, very happy.
My name is Nicole Fogel, and what do you think the first thing you're going to do when you get back to Earth?
Well, that's a good question. Samantha and I are going to land together in the same Soyuz along with our Russian friend Anton Shkaplerov. And Samantha and I are going to get on an airplane with a NASA crew of folks, and we're going to come directly back to Houston. But I think one of the first things that I'll probably want to do is get a shower when we finally get to a shower. There's no showers up here, although we have towels, and basically you take a hot water, put it in a towel, and that's kind of your shower for 6 months. And it's actually pretty good. We can stay pretty clean and stuff, but that's one thing I'm looking forward to doing. Hey, Butch has a demo here. He's going to show you a little bit of physics in space.
Yeah, I wanted to show y'all this. This is just an iPad. Y'all are very familiar with this. Notice how it's almost twice as wide as it is long, or twice as long as it is wide. So because of that, because of the momentum and how that affects it, if I flip it just right, it will flip twice, and then it will roll the next time, and it'll keep doing that. So let's see what happens.
There goes the roll. It flips a couple times and then it rolls over. So when you guys take physics class, your physics instructors can explain mass moments of inertia, and it's cool being in space because you can actually see it in action.
There you go. Thank you. You can go ahead.
Hello, my name is Jadzia Murphy from Cardozo Education Campus, and I was wondering what kind of work or research are you three doing currently up in space?
Well, it's actually been really interesting. We just had this cargo vehicle arrive with a lot of science on board, and so we've all been busy all day, every day, even on the weekends we were doing science. I'm doing material science right now where they're measuring how materials, as they cool, how they become coarse and how the molecules inside these melted liquids as they solidify, how they change. We have a plant experiment in the Columbus module, in the European module down the way there. That's really cool. It's got this big pink light, so at nighttime when you turn all the lights off, the whole station is glowing pink. And we grew some plants. I think today Butch harvested some plants. Samantha was working with fruit flies. We had an experiment of fruit flies. This past weekend I was taking these little worms called C. elegans, and we fed them some bacteria, Salmonella and E. coli. So they were happy at first to eat them, but these are obviously things that make you sick. So they're studying how the immune system on the worms are affected by the disease, and hopefully that can help us out on Earth. So the last few days has been a lot of different science that we've been doing. It's been pretty interesting.
My name is Liliana Scott, and I am homeschooled, and my question is, what do you do for fun to pass time in space?
I think most of us really enjoy taking pictures, spending time in the cupola. This is this magnificent window on the Earth we have. We see the Earth from horizon to horizon, so we actually see very well the curvature of the Earth. And of course, we can also see the skies above the horizon. For example, yesterday, Terry and I were hunting for Comet Lovejoy, which is visible from Earth as well. I think it will still be visible for a few weeks, so you can come and hunt for the comet yourself. So we enjoyed doing that last night. I enjoy immensely finding places on Earth that maybe have a special significance or that just speak to me because of their geography and they're so interesting, or most of the time it's just incredible beauty. I mean, it's an ever-changing colors and shapes and place of shade and light and the sun glint and clouds and a desert and ocean and mountains and plains and snow. It's just an incredible infinite variety that no artist could possibly come up with, and it's just very, very beautiful.
What are you doing there, Terry? You and what's Butch doing?
Actually, he said he could see you guys. He's showing them one of the cameras we use for taking pictures of the Earth. And recently, the lab window has been free. We've been able to take pictures in here. Normally, it's got a payload in there, but so we've got these big, giant, they're almost telescopes here taking pictures of the Earth.
My name is Katie Quinn, and I was wondering, what's the coolest thing to look at in space?
You know, Katie, man, that is hard to pick the number one thing because so many things are cool. And every day it's like, I can't believe I'm seeing this. You're seeing creation from the heavens. It's awesome. But for me, I think auroras. Being from Maryland, we don't see a lot of auroras down there around the nation's capital. And the view you get from here is amazing. You can see them with the naked eye. When you see pictures of them, they're even more magnified. But that is a pretty amazing thing.
Hey, Butch, Terry, and Samantha, I really want to thank you all for the time you gave us today. It was absolutely incredible for these kids. They're telling me you all have to go back to work. So thanks again. Hopefully I will get a chance to talk to you again in a few days. Take care.
All right, super. Thank you, General. Hello to everyone. Y'all have a great day. Have a great time.
And thanks very much, Houston. Okay, so hopefully that...
Thank you. That concludes our event.
Okay. Hopefully that was exciting for everybody who got an opportunity to ask a question. I'm really sorry everybody didn't get an opportunity to ask one. But, there are several things that you heard. One was about studying really hard, about being passionate about what you do down here. No matter whether you know what it is you want to do as you grow up or not. But I think every single person that you're going to talk to on the panel coming up, those that we had an opportunity to talk to earlier, you kept hearing us say that. Just find something about which you can be passionate and then follow it and don't give up on it. You know, the Obama administration is really committed to STEM. And if you've heard the president in the past, he's set a goal of recruiting 10,000 10,000 STEM teachers in the next 2 years before his term is over. And that's part of a long-term goal of recruiting 100,000 teachers over a decade. So some of you who are in high school right now, and eventually some of you, may have an opportunity to be teachers or scientists or engineers or whatever. So our message to you, study really hard, work hard. Whatever you do, don't ever be afraid of failure. Don't be afraid of trying something because you think it may not work or you may fail at it. So thanks so much for the time that you gave the crew. They enjoyed talking to you. They always do. And I'm going to turn it back over to the moderator, and we're going to get into a really interesting panel here, and I'm going to listen for a change. So thank you all.
Thank you so much, Administrator Bolden. Let's give him a round of applause again. So awesome. And I know not all of you were able to ask all of your questions, but fortunately, on our panel, we also have NASA's Chief Scientist. So for all of your space-related questions, you still have an opportunity, which is great. But before we get to our awesome panel, there's another person from my office, the Office of Science and Technology Policy, that I want to introduce to you. Her name is Jo Handelsman, Dr. Jo Handelsman. She is our Associate Director for Science, and that covers a lot of territory. She is a microbiologist by training. Who knows what microbiology is? Okay, a couple people. For the rest of you, I'm really glad you're here. You're going to learn a little bit about microbiology, which is fascinating. And I will turn it over to Jo to do just that, to talk about everything that she's done.
Well, hi, everybody. Do I get a hello? Hello. All right, thank you. Well, it's great to be here with you today. I love meeting with students. I used to be, and I will be again, a professor at a university, and I taught students all the time, and now I only get to teach one student, one really, really smart student. Who do you think that might be? The president. He is the best student of science. He loves science. He says he would like nothing better than to talk science every day. He always takes time with scientists to ask questions that totally bowl them over. He asks these really smart questions, and you wonder, how in the world does he have time to read about that, whatever topic it is, and still be president? I brought a bunch of cosmologists into his office. Anyone know what cosmologists are? Yeah, okay, study the universe. So these are the people that figured out that the universe is expanding, right? We didn't think that for a long time, and there were a few people who thought that, and they ended up getting a big award. So I took them up to meet the president. And the president sat down in the corner of his desk, and he started chatting with them about cosmology. Well, these scientists were kind of floored, because most people can't even define the word. But the president was very, very fluent in that. So, and that's about every topic that, that you talk to him about. So my next topic that I want to talk to him about is microbiology. So I thought I'd practice on you first and see if you like it. So a few people said they know what microbiology is? Yeah, what is it?
So microbiology would be the study of smaller organisms that the human eye cannot see.
Great. What's your name?
Gabriel Solomon, and I attend Cardozo Education Campus.
Thank you, Gabriel. Good job. Yep, microorganisms are those teeny ones we can't see with the regular eye, but fortunately we have microscopes which magnify them. Just like telescopes magnify the planets for us, microscopes magnify the really tiny things that are right in front of us. So when I was 12 years old, I was in 7th grade, and I took my first science class, and I was really scared of science because I thought it was going to be all electric. I don't know why I thought this. I thought it was going to be all electrical circuits and making light bulbs light up. And I must have read a book or something that had a picture of that in it. So I was petrified to go to 7th grade. My sisters, who were both older, said, no, it'll be okay, you'll be good at it. And I figured, no, but I'll survive, right? And I got into the class, and I realized that this was what I wanted to do with my life. I looked through a microscope, and I saw what's called a paramecium, a little one-celled organism that swims around with these hairs that make it swim. And the best part was, that it has a mouth. This is one cell, really sophisticated for one cell. And it sweeps the food in with its little hairs. So we fed it a red dye, and you could actually see the little red crystals go into the mouth as it swept them in. Well, I fell in love. That was it for me. So I was a babysitter at that time. That was my income. And so I saved up all my babysitting money for 6 months, and I bought myself this really, really old microscope. It was actually imported from Germany back in the 1930s, so really old. But it worked. They knew how to grind glass and make lenses back in the 30s, so it was fine. And I spent most of my teen years looking through the microscope when I wasn't in school. And I'd go to the nearby pond and take samples, and I noticed that every time I went, I saw different things in there. And then I would put things from my fingers on and from my mother's hairbrush. And I found things all over that were really fascinating. Of course, I had no idea what they were, but they were cool to watch. So that's the kind of passion that Dr. Bolden was talking about. You find something that you just love. And even though your first impression of that, like mine of science, was all going to be about light bulbs, it might be wrong. You know, you might not really know what it's about. Give things a chance, and then maybe you'll find your passion in there. So we work on a variety of things in the Office of Science and Technology Policy. But one that we're just moving into now is microbiology. And it's not just because I'm interested in it and I've loved it since I was 12 years old. But we've learned a lot about microbiology in the last 20 years that tell us that we, in fact, don't know that much about microbiology. We thought we knew a lot. But what we discovered in the last 20 years is that only a very, very small number of the organisms out there in the world, those little ones that we can't see, will actually grow in the lab. So it's like 1 in 100. So for every organism that we can grow in the lab and that we can study in the lab in a very simple way, there are 100 others or 99 others that we can't grow in the lab and we don't know what they're doing. So that's the future of microbiology, and that's why we need people like you, because we need smart people to figure out how do you study a bacterium or a fungus, whatever kind of microorganism it is, without being able to grow it on a petri dish. That's how microbiologists typically grow things, around these circular discs where they put some jello-like stuff and bacteria or fungi grow. If you can't do that, what do you do besides look at them through the microscope, like I did when I was 12? There has to be more to do. So that's what scientists are struggling with now. How do we study organisms that won't grow in the lab, won't behave like good, obedient organisms? And then what are they all doing? And one of the things we found out is that we have 10 times more bacteria in our bodies than we have human cells. People know what a cell is? Yeah? Yeah? What's a cell?
It's one of the building blocks of life.
Okay, it's a building block of life, the smallest of the biological pieces, right? Well, we have a number of trillions of cells. That's a pretty big number, about 100 trillion cells in our bodies. And it turns out that 10 times more of them are bacteria than human. So doesn't that sort of make you question your identity? Are you really human, or are you a microbe, a really big microbe? Well, that's a good philosophical question, but we're only in the first stages of figuring that out, because that was a surprise. That was figured out quite recently, and scientists said, whoa, there's a lot more here than we thought. And it's only that they're so tiny that we can't see them. Otherwise, they would look like more than us. We wouldn't look like humans. We'd look like a big blob of microbes. But they're really tiny. But there are that many of them. Isn't that amazing? You have trillions of microbes inside of you, on your surface, in your mouth. And they're always changing, and they're always responding. And what do you think microbes do?
My guess would be they can either make you better or make you sick.
That sums it up. They can make you better or they can make you sick. Well, a few years ago, people only thought they could make you sick. Yes?
Once I saw this kind of a video at the Natural History Museum about like it was about things that are too small for the human eye, too big for the human eye, too fast for the human eye, and too slow for the human eye. And there was a part that was too small, and there was this camera that could like see things that were very, very small, and it went like it was like a dog's eye kind of, and it went in deeper and deeper, and I think it's kind of like that.
So you saw something that can see tiny little things, and it can focus in and magnify them more and more and more at the Natural History Museum? That's exactly right, and that's what a microscope does. And now there are lots of different kinds of microscopes where you can see a whole mass of microorganisms, or one, or like you're thinking, even inside of one microorganism. So yeah, we can see them now in a bunch of new ways. And through those new ways, we've figured out that some of them are bad. They make us sick, right? Viruses. Anyone ever had a virus? Yeah? Everyone ever had an earache? That's caused by bacteria? Yeah, so you've been sick. Well, we're always saying germs are bad, bacteria, viruses, those are all bad things. Turns out a very tiny percentage of microbes make us sick. The rest of them make us healthy. And there are thousands and thousands of different kinds that keep us healthy. So microbes are really great for us, and it was only because people were kind of prejudiced against them that it took us so long to figure out that they keep us healthy and not just make us sick. Because 100 years ago, when we first discovered them, we discovered them because they were making people sick. They were making people die, in fact. So scientists wanted to figure out why that was. So after that, everybody had this bias. They had a slant, a view, that when they discovered a microbe, they figured, oh, it must be a bad one, it must make you sick. And it took us about 100 years to figure out, as a result, because we were kind of blind to it, that in fact, most of them are good. So I want to go back to something that Megan said earlier. One of the other things that our office and the Office of Science and Technology Policy does is we study why girls don't go into science as often as boys do. And it turns out that if you look at every measure, girls are just as smart in science, they do just as well in math and science, they have just as much interest initially, but very often they leave. They stop studying science, or they stop going for careers in science. And so we're trying to figure out why that is. And one of the reasons, there are a few, but one of the reasons is people sometimes discourage girls from going into science. And sometimes that's because of a bias. And it's just like the microbes, where for all those years we couldn't see that they're really good organisms because we had kind of blinders on. We just believed all microorganisms are bad, so that's what we kept seeing. And it's kind of the same thing with girls. People have seen boys and men as scientists, right? The history of science is filled with them. You look at the textbooks, you see all these men who are great scientists. But it turns out girls and women can be just as great. And we have to get rid of that bias. So if people tell you girls can't do science, unfortunately, I still hear that, don't believe them. And if you get discouraged, think about, is somebody discouraging you? Maybe they don't mean to, but maybe they're kind of discouraging you from doing this, but this is really what you want to do, so don't listen to them. Go and get it anyway. And remember that sometimes the adults who are telling you what you're good at and what you're not good at and encourage you this way or that way, sometimes they don't know what they're talking about. So sometimes you just have to make up your own mind. So with that, I'm going to leave you with thoughts of microbiology and bias and just take a couple of questions before we go to the panel. Yes?
I had a question about microbiology. How much of what you're doing with how much of what you're doing with microbiology right now is related to microbiomes? Because I know you mentioned the microorganisms that we have in our body, and so I was just wondering how they're related.
So a microbiome, this is a great question. A microbiome is a collection of microorganisms that live together in some place. And the place could be soil, for example. That's one of the things that my research group studies, is the soil microbiome. And that's all the organisms that make soil soil. And then there's the human microbiome. And there are ocean microbiomes, all sorts of different ones all over the world. And it's really funny that you ask, because I'm at a meeting today, the rest of the day, called the microbiome. And that's exactly what we're talking about, is all the different microbiomes there are, and how can we study them together and look at the human microbiome and the soil microbiome in the oceans, and maybe the one on Mars someday, and figure out what the principles are that govern all of them if we do comparisons among them.
If I wanted to be just like you, what would I have to study in college?
Oh, that's nice. Well, first of all, I hope you're not just like me. I hope you're way, way better. So first of all, you have to find people who encourage you. That's the best thing. We sometimes call them mentors, sometimes advisors. Sometimes they're just friends or relatives. But you have to have heroes and mentors who tell you that you can do this. And you can, because science is about hard work. It's not about being some different species or something, which a lot of people think it is, that there are scientists and then there's everyone else. Anyone can be a scientist. It just takes a lot of hard work and wanting to do it. So that's the most important thing, is find your passion. And then for my career, I studied biology. I actually thought I was interested in plants when I went to college, and I wanted to study agriculture. So I studied plants in college, but the microbes kept pulling me back. And so then when I went to graduate school to get a PhD, I studied plants and bacteria that interact. And then I said, forget the plants. I'm just going to go with the bacteria. And that's kind of what I stuck with. So there are lots of different routes to the same end. And you can change careers. You can become a physicist and then switch to biology, or the other way around. So what you really want is a well-rounded scientific background, lots of courses in lots of subjects, because you never know in science what you're going to need and what you're going to draw upon. Does that help? All right, do we need to stop? Okay.
I think it's time for the panel.
We need to do the panel. So hold your questions and we can ask the panel, okay? We've got a great panel coming up. Okay, could my panelists please come up? Oh, I'm sorry. I'll stand. Sorry about that. All right, so we're really lucky today. We have this amazing panel of great scientists who have done very different things with their lives. So we have Rachel Harrison Gordon. We have Nicole Hernandez Hammer. We have Lynn Murdoch. Murdoch, is that what I said? Sorry. And Kathy Pham. And we're gonna, let's give our panel a big hand. They're really something. Ellen, I'm sorry. Sorry. My friend Ellen Stofan, who's from NASA. I'm sorry, you weren't on my sheet. So you got your own private applause. That's better. All right, so I'm going to let the panelists tell you a little bit about themselves as you ask questions. But why don't we start with some questions and use those to guide? Is that okay? All right. Who wants to ask the first one?
Right here.
I was wondering, how did you guys get into the positions that you guys are in today?
Sure, I can start. Sure, that's a great question. I started as a park ranger out in Flagstaff, Arizona, where I went to college. And I originally started as a volunteer in the parks. I was writing a couple papers on the topic of geology. And then I got to work with several of the staff in the area and was very interested in the Park Service. So that was my first seasonal position.
I'm a planetary geologist, so I study volcanoes all around the solar system, and I got interested in it when I was a kid. I thought it was really cool to study the Earth, to try to figure out Where do mountains come from? You know, how do rivers form? Why is the Earth the way it is? And then I realized, oh, you can do that not just on Earth, but on all the planets. And so I studied hard in school and got a PhD in geology and went to work with NASA programs and got to explore the solar system. And luckily, Administrator Bolden needed some science advice. So I got to come and work for him, which is really, really fun. So I get to do not just studying planets of the solar system, but learning about all the science we're doing on the International Space Station, learning about studying planets around other stars. So cool stuff.
So I'm Kathy. I studied computer science, and I want to be like Ellen when I grow up. I got into computer science because I had an awesome high school teacher that just decided to teach computer science my senior year. We didn't have AP classes like computer science, and we didn't have a lot of robotic support or anything like that. And she just took the initiative to teach this awesome computer science class, and I fell in love with it. And then went to college, studied computer science, and really got interested in healthcare and data. And that was kind of my sticking point. I just loved healthcare, loved data, and loved computer science. And that was kind of what took me along the journey of what I did, where I worked for companies like Google and IBM, and now I'm with the United States Digital Service.
I'm Rachel. I studied mechanical engineering because I grew up playing Legos and Kinects and Roller Coaster Tycoon with my grandpa, and really loved using my hands to build tools and products that I hoped would improve the lives of the people who used them. I thank my mom for introducing me to a summer program called Principles of Engineering Design, where I learned that all the things I like to do made up a field that I could study. So I went to Penn, but I really wanted to better understand the people who would be using my products. And that's how I started getting into entrepreneurship and computer science to study data around how people, for example, read the New York Times, which is where I spent a little over a year learning about how our consumers would engage with content on different mobile devices. And being able to segment our audience is a skill I hope to apply as a Presidential Innovation Fellow this year with Veterans Affairs to better improve their user experience and the services that we provide.
My name is Nicole, and I got into my career when I was young. I really loved being outside, and I loved playing in the woods and looking at trees and plants, and so I knew I wanted to study science. And then when I got to college, I kind of was afraid of math, and I took a math course and I failed it. And I took it again and I passed it. Then I took the harder level and I did even better, and I kept going higher and higher because I just loved it. I really love using numbers to solve problems. So when I graduated with my bachelor's degree, I decided to get 2 master's degrees. I got one in biology and one in finance. So one to study the natural world and one to kind of play around with numbers. And so I kind of looked to kind of try to figure out what career would be best for me. And I kind of fell into a category of interdisciplinary scientists that like to look at all different types of ways to use scientific information and kind of put it together. And the best fit for me and what interested me the most was climate change. So I took kind of those 2 things, and it helped me figure out how the natural system affects the system that we live in, and how it affects our economics and our communities. And so it's been a great opportunity to use what some people think is a weakness, that you like kind of a whole bunch of different things, and actually it can be a real strength. So that's how I got into what I do.
So can I ask a quick question of Ellen? Ellen, just so that you know, I really did notice you, but I was admiring your friend there. Could you tell us about your friend?
Yes, this is my friend, the Curiosity rover. Can somebody tell me where the real Curiosity rover is right now? Right there. Yep.
I think on Mars.
That's absolutely correct. The real Curiosity rover is on Mars. It's climbing a mountain named Mount Sharp in the middle of a crater called Gale Crater. And as it climbs, it's making all kinds of measurements of the rocks. And what it's learned is that there used to be a lake inside Gale Crater. We know there were organic compounds in some of the rocks that have been preserved that Curiosity has measured. So what we're really trying to find out is that we've been able to confirm with the rover is maybe that lake, millions and millions of years ago on Mars, is an environment that could maybe have had life. And so that's what we're trying to really understand. Did life evolve on Mars? And
Wow.
curiosity is helping us figure that out.
I like your friend.
Really?
Cool.
My name is Samantha, and I'm in Maury Elementary in the 5th grade. And my question for you guys is, what inspired you?
Okay, I'll start. Actually, what inspired me is I really enjoyed working with the Park Service, right, even when I started as a student. And it was kind of a joke when you first were hired with the Park Service. People would say stuff like, oh, you get paid in sunsets, because, you know, you generally don't get in that field, you know, for the finances. But it wasn't really sunsets or things that inspired me. It really was, you know, being on the ground, leading hikes. I did, at Point Reyes, my job was watching whales, pointing whales out to people and explaining what spy hopping and breaching is and different species of whales. Leading tide pool walks. At Glacier, I would lead people on 10-mile hikes, you know, through several different plant communities. And at the end of the hike, I mean, people would basically say, you know, I'm going to quit my job and move here, you know. So from an inspiration standpoint, that was my inspiration, really, was to kind of keep people engaged in the natural world.
You know, when I was a kid and I was thinking of becoming a scientist, one of the things that inspired me was reading about women scientists, people like Mary Leakey, who were going and studying the origins of the human species. And then as I was growing up, I got to meet scientists like Carl Sagan, who were studying the universe and how it formed. And now, you know, when I'm in meetings all day and sometimes we have problems that are tough and we're trying to figure them out, then I get to go and talk to kids, people like you guys, who remind me that exploration, whether it's understanding a biome, understanding Venus, understanding Mars, understanding planets around other stars, is really, really cool. And to me, that's the best part of being a scientist. You get to do really cool stuff. And so a lot of the times, you guys inspire me to stop complaining and go back to work and get back to work.
When I think of kind of what inspired me when I was a kid growing up, the two people I distinctly remember, well, there's my mom, but there was also Mother Teresa and Princess Diana. And I remember just thinking that they just had this heart for service, and it always kept me focused on just reminding me of everything that I have here in my environment, how lucky I am to live where I live, in this country, in my home, and to see how the rest of the world lives. And it always inspires me to think of what else I can do to make the world better when I look at what I have today. So usually what really inspires me is just thinking of how I can use the talents that I've been given to really improve the lives of all these other people who just have not been given as much as I've been given. And then two other people in my life who really inspire me are my mom, who recently beat her battle with cancer. Hooray, hi Mom. And my brother David, who's a captain Marine Corps, and he's sitting out there today. And so they both also inspire me every day.
I'm also going to steal part of the mom answer. I just had a tough lady as a mom who raised me by herself and fought through her own battles of stereotypical female roles. Her parents encouraged her to go to secretary school, and she sort of ditched that and went to law school and navigated her own path with critical male judges. And I'm so fortunate that she helped me be empowered by the mistakes I made instead of debilitated and discouraged. Something also that helped was I went to an all-girls school where we were just, exactly, and I think about it every day. Those are my best friends for life, because in that environment you just support each other and accept each other, and you act goofy and it's okay, and nerds are cool in their own way. And they helped me have this determination that stuck in the back of my mind when I was in classes with all boys who didn't want me in their group because they assumed I was dumb or just too emotional. And I just thought back to Kent Place School in Summit, and with wisdom she lights the way, and I'll never forget that. You need mentors and a supportive peer system.
I'm going to copy you guys and say my mom too. We lived in mostly urban and city environments, and so we didn't have a lot of easy access to nature, but she really made an effort to take me to parks and kind of explore the natural world, and so that's why I love it so much. And then also, when I first started college, there was a professor that let me hang out in his lab, and I just showed up one day and I said, I'm interested in what you do, can I kind of just hang out here? And he said, yeah, sure. And he let me play with some of the equipment. And, you know, being an academic now, I kind of see like, wow, why would you let a first-year college student just come in and kind of mess around with your lab stuff? But it actually got me really interested in science, and it kept me going throughout college when some of my other friends kind of changed and moved away from the sciences into other areas. So to Dr. Essig, I am very grateful.
Okay, we've got one over here.
I had a simple question to Ms. Rachel. What's the next step after you build Legos?
Sorry, what did you say? Could you repeat the question?
What is the next step when you finish building Legos?
Oh my gosh. It was really this summer program. It's Johns Hopkins hosted program, and they have a whole bunch of STEM courses. And I got to study on a college campus. I think I was 13, learning introductory level physics, got to build some prototypes in robotics. It was just a natural step forward. That was a little more stressful than sitting behind a computer building roller coasters, but used the same skill set. So I would look for interesting summer programs or maybe after-school courses that just pique your interest. And you don't have to, they're not high-pressure environments. They're fun because you're with your peers.
I have a question for Kathy real quick. What was it like sitting in the First Lady's box last night during the State of the Union?
Nicole was there as well, so
really?
It was wonderful. It was a wonderful honor. The President and First Lady are incredibly gracious people. I think my favorite memory that I will hold on very, very dearly is at the end of the night when she gave me a big hug, told me that my mom should be proud of my brother and myself, and just wished my mom well and a good recovery. And they're just wonderful people. It was a great experience.
And Nicole?
Yeah, I agree. It was incredible. They were so gracious and kind, and opened up the doors to their home and let us kind of hang out for a long time. And they were really concerned and knowledgeable about the issues that we work on. And that just really meant a lot to me, a lot to all of us.
Oh, and one question I did get asked afterwards was what it was like to, like the exercise bit that we had where we just were sitting down and standing up and sitting down and standing up. It was definitely quite the workout.
Ruth, go ahead.
I'm Ross Clark from Cardozo Education Campus. I'm an 11th grader. All right, my question is to everybody. What is the most challenging thing in your lines of work today?
Okay.
Great question. Actually, probably the most challenging is really remembering, remembering the mission. For me, the mission is the National Park Service. Our mission is to provide for the enjoyment within national parks, to protect the wildlife therein. I mean, it's a very noble mission. And when you're a field ranger working at a park like Katmai in Alaska or at any of the parks I've worked in, it's pretty easy to connect with the mission. You live it, you breathe it. In DC, it's a little different because what I do now is more work for advocating education programs, STEM programs, work with partners. It's great work. It's just you're not out in the resource every day. So you have to really remind yourself and be true to, to your convictions of why you got in this for the first place. So I don't know if that's the biggest challenge I have, but it's surely important for me to really always keep the joy, in my life and the passion, and remember why I got in this in the first place, and don't let politics get you down, I guess.
I have two things that are a little bit different. The first one is, I'm really concerned about climate change. This past year, last week, NASA and NOAA both announced that 2014 was yet again now the warmest year on record. Climate change is a huge challenge that we're facing as a country, and NASA is making lots and lots of measurements. We just launched 5 spacecraft in the last year to make new measurements of Earth to help understand how it's changing. And we've got to do everything that we can at NASA to make sure people understand our data, can use our data to help understand how our planet is changing and what we can do about it. And the other part is a little more fun is we want to send humans to Mars. How cool is that? Who wants to go to Mars in this? Do we have potential future Mars astronauts? So that's a challenge. 8 months to Mars, 8 months back, really thin atmosphere, hard to land on the surface, big engineering challenge for how do you keep humans healthy, lots of work, we need help, sign up at the door, we'll hire you.
Let's see, for me, I think the most challenging thing is also the most exciting thing. It's when someone tells me no, to figure out how to get around it and to not take that as an answer. That's not unique to what I do today. It's happened throughout my life when someone says you can't do something or something's not possible, to basically say, oh, I don't know about that. Let me go figure out how it's possible and really explore all the options before I determine for myself whether something is or is not possible. And then my day-to-day job, right now, something that I care deeply about is connecting healthcare data for all people. And so there are some challenges there with the way we've built various electronic systems around the country. So that would be the more technical challenges that I'm working with today.
Excellent. I actually get to work with Kathy within Veterans Affairs. And it's been a really exciting challenge because I got to go on the road and meet 100 vets and hear their motivations for joining the military and hear these amazing, powerful stories of their service and some pain points about transitioning back to civilian life. And the pressure was always on to create services that made a significant impact in their lives. But now I have these faces in my mind reminding me of why I'm here in the fellowship. So one of the struggles I have is being able to focus on one area where I could improve their lives instead of becoming overwhelmed with all of the opportunities that exist in this massive organization. Also, invigorating people to change things. We've been using very old health record systems, and there's policies that are out of date or less effective than they could be. And it's just about encouraging people who want to do the right thing to do the right thing.
Well, a lot of what I do is educate people about climate change. And usually when I tell people about the impacts that might affect their communities, they ask me, what can we do about it? And I talk a lot about policies. But what we also need to start doing is thinking about ways that we can learn to adapt to the new normal, because we know there's some climate change impacts that we're not going to be able to avoid. And right now we don't have a lot of tools to adapt in sustainable ways. So right now we manage floods by pumping, and these pumps take up a lot of energy. And so I think, actually I'm very encouraged to see all of these young bright faces here, because I will be looking to you in the future for creative and innovative solutions that not only will help the US adapt to the changes in our environment, but then can also be used to help other countries adapt as well.
One back here, ready? Hello, my name is Claiborne Castañón, and my question for you is, what is the funniest thing in your job?
The funnest thing in my job? Boy, there are a lot of fun things. There really are. I get to travel to a lot of parks, and I get to work with really great people. And I do get to do a lot of work with kids. And I have to say, work with kids is probably one of the more fun and motivating factors of my job, because because it's just fun. I like to do teacher workshops. I like to take kids in the field. I like to teach ecological monitoring and really see kind of when the light bulb goes off in the kids' heads.
You know, probably the most fun part of my job is when I get to do stuff like this, because you guys always ask the best questions, and they make you think, and they make you think, how can I do my job better, or what am I working on? So that is probably the funnest part of my job. But the other part is just learning new things. I get to learn, like, why do bacteria become more virulent, more nasty up on the space station? Some of them do, some of them don't. Why are there black holes at the centers of galaxies? I don't know. We don't know, actually. So you get to learn about everything that's going on at NASA, and it's really cool. So that's the funnest part of my job, is talking to the people who do all that cool research.
I'm going to have to agree with Ellen, the first thing she said. It's so great to meet people like you guys. You come up with just so many great questions and ideas, things that we might not have thought about yet, so keep bringing them to us. It's lovely. The other part is working with people like Rachel day to day. It's fantastic being able to work with such smart, motivated, excited people, and just to solve really hard problems. It's kind of fun when someone brings you this problem and they're like, this is kind of impossible, or no one's ever been able to solve it. Can you try? And you're like, yeah, I'll take a stab at it and see what I can do. So that's a lot of fun.
Definitely copying some answers. Through this fellowship, have gotten to meet so many smart people from incredible backgrounds that are brilliant but also extremely goofy. There's someone in my program who now works at the IRS, and he decided to build a ball pit in his apartment. So he put gallons and gallons of these plastic balls that you see at McDonald's and shipped them all the way here, and invites people over to jump around in this very silly pen that he built. But knowing that there are so many dimensions to people was unexpected and an adventure every day.
Yeah, I have to say adventures too. I've had so many interesting adventures. I've gone up in helicopters with photographers taking aerial pictures. I've gone out in boats on the ocean. I've gone in airboats in the Everglades. I've traveled to all sorts of different places to talk about how climate change affects different groups and different people. And you know, I've gotten to come here today to talk to you guys. And so yeah, I just have such a great collection of adventures and interesting people that I've met. I have so much fun, and I really enjoy what I do. And so, yeah, that's what I love the most.
We also got to come to the White House.
Yeah.
That's fun.
That's pretty awesome, too.
Well, let's take some questions from our Twitter audience. Do you have any, Becky?
We do. So we have a question for Ellen from Twitter user Logan Jacob, who wants to know, are there animals or other living things in space?
Well, Logan, we'd really like to know the answer to that question. And so what we're doing at NASA is trying to figure out where should we go and what should we look for. And certainly that's one of the reasons we're going to Mars. We have the Curiosity rover. Right now we're looking for things like organic compounds. We're also looking, because we think the life on Mars might be fossil life, so we have cameras that look for that, look at the rocks. But part of the problem is the life on Mars might have been that microbiome. They might be really small. So we do have a microscopic imager, but the life's going to be hard to find. So we also are going to places like, we want to go to a moon of Jupiter called Europa that's got a thick icy crust. Under that icy crust is an ocean. We don't know. Maybe life evolved in that ocean. I don't know about animals, but you know, you can start thinking, what kind of life could have evolved in this ocean on another moon? Then we're looking at planets around other stars. Planets around other stars we've been detecting with a space telescope we have called Kepler. We now have well over 1,000 planets that we're trying to study. We're going to have a new telescope called the James Webb Space Telescope that's going to start studying the atmospheres of those planets, and we're going to look for signs that there might be life. So we don't know the answer to that question, but we sure are working hard to try to find it out.
One more Twitter before we go back. Any others? Nope. Okay. Faye?
Sorry, I have to walk over.
My question is, how long have you been working on your projects?
process here.
Yeah, why don't you guys start?
Okay. I've been working in my field for about 15 years.
I graduated college in 2012 and have worked at an EHR software startup for a year, New York Times for a year, and then a financial data analytics company. And then I've been in this fellowship with Veterans Affairs for about 4 months.
Similar to Rachel, I've been to different places in the last 7 years I've been working. Kind of started out as an intern for Google Health and got into healthcare that way. And then I worked for Harris Healthcare Solutions and IBM and Google, and now I'm with United States Digital Service. I've been here for a few months, focusing on the VA.
Well, I've been studying planets for over 30 years, but I've been, I know, really long time. I've been Chief Scientist of NASA for about a year and a half. So projects, really vary in length. We have projects at NASA that go on for a really long time, partially like our New Horizons spacecraft that's on its way to Pluto. It's taken almost 10 years to get there. So sometimes you get involved in projects that take really long times. Then we have short projects that you might only work on for a year, but it's always working in teams, which is really fun.
Yeah, and I've been with the Park Service for about 30 years, also a really long time. But in the Park Service, you can work seasonal positions. So I worked a number of seasonal positions at parks, and then I became permanent. And when you're permanent, that's more when you hire, you train, you live in the park, and that's so I was at Glacier for about 10 years and Point Reyes for about 4. So some parks I stayed longer at. I've been in this position now. My title is a Natural Resource Interpretive Specialist. So I work for Natural Resources Science and Stewardship, and I've been in this position since the early 2000s.
And for science projects, they're never really done. You may answer one question, but in science, a question always leads to more questions. So you're never done with science. That's why we need more scientists.
Yes. What technology careers do you think will be most in demand in the next 10 years?
Who's our futurist today?
Yeah.
I mean, I may be a little biased, but I actually think healthcare technology will be really big. We've been gathering all this data for all these years, and somebody has to do something with it. So maybe you guys can tell us more about our healthcare data.
I think lots of technologies that have to do with climate change. How to have better energy sources so that we don't put CO2 into the atmosphere. How to deal with the effects, as Nicole was talking about. How do we deal with the effect that sea level is going to rise and we're going to have all these changing things? So lots of careers to do with climate change. And then, of course, I'm going to always plug our journey to Mars. We need engineers. We need astronauts of the future.
Along the lines of climate change, I'd be interested in seeing how our biology changes to adapt to new environments. I can see that working its way in there.
No, you guys have got climate change covered.
Well, actually, I was actually going to mention climate change too, just from a standpoint. I haven't gotten into it real heavily with the Park Service. We're definitely, of course, we've got a whole climate change response program. We have a number of work that's aimed at measuring, developing indicator species. But really the way we look at climate change within the parks is we stand by the science that's going on in the parks. Then we look to work with maintenance or other divisions if we can do some kind of adaptation or mitigation. So to me, that's a real exciting part that now people don't just sort of, not that they built blindly in the past, but I mean, people really take into considerations what kind of changes are coming onto the landscape and sea level when they're going to be putting federal dollars into facilities. So that's definitely an aspect.
And can I add on a lot of the projects that I've worked on in studying climate change and specifically sea level rise, we find that the best groups are made up of folks that have different areas of expertise. So in climate change, we need architects, we need engineers, we need biologists, you name it. So it's a really interdisciplinary field. So back to kind of the idea is if you have a couple areas of interest and you can find a way to bring them together, climate change is a great topic to do that in.
And I can only guess that nobody's mentioned microbiology yet because you assumed that it was one of the fields of the future. All right, that's all right. I'll let
I
you
have
get
one
away
more
with it.
add to that too. I know we talked mainly about things like healthcare, climate change, and microbiology, but I look at my landscape of people who graduated with me, whatever it is you're interested in, whether it's clothing, retail, volcanoes, space, cars, tech, whatever it is you're interested in, today you can probably find a field in science and technology where you can apply yourself in those areas. So whatever it is you're really passionate about, you may not have to let that go, but also explore a STEM field.
Okay, so we've got about 5 minutes left. So everyone who wants to ask a question, make sure you get your hands up, and we'll try to get to as many as possible. This will be the rapid fire round.
My name is Dakota, and if any of you went to any other state or country, have y'all studied any fossils?
Fossils? I have not studied fossils.
You know, I was just in November, I was in Chile. I went down because we had a NASA aircraft that we were taking down to fly over Antarctica. So I actually went and flew over Antarctica because we were using our NASA instruments to study the fact that the ice sheets down there are melting and they're not in a great state. So we had our aircraft down there. And they took me to a museum and showed me all kinds of really cool fossils. And I thanked them because I said, anywhere I go, if I can look at rocks, I'm going to be happy. So there's all kinds of cool fossils I saw from Chile.
And we, of course, Park Service, we have about 400 plus units. Many of our units are focused on fossils. I have spent most of my time out west, so I'm most familiar with fossils in parks out west. I know there's a lot here in the east as well. We also now have a National Fossil Day, which we just held at Smithsonian October 15th, where we brought in school kids. We've got a website now where we do lots of games and activities about fossils. So what we're trying to do is both educate kids when you're in the park and you can see the fossils, but also understanding what kind of landscape produced the fossils, what kind of climatic changes are going on now, and a lot of that's more stuff on the web that we provide.
All right, let's do a few more questions really fast, one answer each.
Hello,
Luis?
I'm Carlos Hernandez, and I go to Cardozo Educational Campus, and I am one of 3 students here that made an app. And my friend here, Francisco Delgado, and my friend here, Gabriel Solomon, are the other 2. We placed best in state with our app in the Verizon App Challenge. It was called EDU Central, and we wanted to know, I had a personal question for both Kathy and Rachel. As if I'm not mistaken, Rachel, you're also a computer science, correct? All right. The question is, since we placed best in state, and we've also had more moral support from not only the parents, but faculty, everyone that we've showed the app off to, would you give us any advice to where we could keep going or what to look forward to while continuing our progress?
I'm not sure what it does, but if you study the needs of your core audience, that will give you ideas of where to market yourself. If it's for students, you could go on college campuses and be part of their career fair. There are other apps that may have similarities but deficiencies that make yours even more valuable. So understanding other apps that you're competing with, essentially. I'd love to check it out. We can talk after and we could play around with it.
Or you're asking for what to do with your app, this particular app? Well, I think Rachel's answer was great. You also just announced it on the whitehouse.gov live site. So that probably also was great help for it as well.
Yeah. Hi, so you are obviously all like very powerful women at the top of your field, and I was wondering if you like faced any bias like because of sexism getting there, and if so, how did you overcome that bias?
You know, I think for me, one of the hardest things throughout my career is just feeling like I'm different from everybody else in the room. Because even still now, you know, when I go to a meeting and I look around the room and I'll count, I always count how many people are in this room that are like me. And I'll be in rooms of 40 people and there'll be 3 women, 4 women, 5 women. And I think that's the hardest thing sometimes is just feeling like, do I belong here? And it makes you sometimes doubt yourself. And so I think one of the most important things in any career that you choose is to be really confident of yourself and say, I'm here because I deserve to be here. I have a seat at the table. And so I think that's really important.
I have to say that I do the same thing. When I go into rooms, I do the count. And at first, I thought the same thing. It made me feel like I didn't belong. But then I realized, no, wait, actually, they're really lucky that I'm here because I've got a different perspective to contribute. So when you're a little bit different than the rest of the people in the room, you should feel like you have an opportunity to look at a problem in a different way. And that really helps move science forward.
I would agree. It's science and also cultural work, because one of the things I know when I was at Glacier, I was one of the only female rangers, and I developed a really intense, great partnership with the Blackfeet tribe, and not that that hadn't been done before, but I just might have had a different perspective, more looking at art, how can we communicate using art, bringing some native speakers, and et cetera in.
Julian from Molly Elementary, and I was wondering if the sea level kept on rising, what would it be like in like 100 years?
Well, different places have different projections, so unfortunately in my hometown of Miami, we're going to lose a lot of land. That's why it's so important that we do two things. We think about how we're going to adapt in sustainable and creative ways, and we also have to figure out how we're going to get energy from sustainable sources. And you know, there are some impacts that we won't be able to avoid, but there are others that we will, and that's why we need your bright minds on this topic as soon as possible.
All right, let's do one more question here.
Hi, I'm Talia Evans. What motivates you and keeps you going when things go wrong?
I guess I'll start. I think just telling myself that there's always a way out and things will get better when things go wrong, and that there's a solution and either myself or my team will figure it out. And so just not giving up, and really when things are really hard or things go wrong, just to remind myself that there's a way out of it and take a step back and just figure it out and not give up.
Along those lines, I think it's important to remember that asking for help isn't a weakness, it's a strength. People can't know everything, so in order to get out of maybe a sticky situation, you should use your resources, your peers, and in that way you'll earn respect and you can pass on your knowledge to somebody else.
All right, should we do one Twitter question?
This one is from Beth Harrison on Twitter, and the question is, if you could have dinner with any famous scientist or engineer, who would it be?
First, I think that's my aunt. So, hello? Really? Oh my gosh. I think way back, I would have loved to meet, I think, Miss Johnson. She was one of she was called a computer, and she worked at NASA, and she helped develop some of the trajectories to make a successful launch and return. She was a minority, super smart, really launched it off, no pun intended, for ladies. I'd love to have them deal with her.
All right, well, I promised that was the last question, and we need to move on. I want to thank the panelists. You can stay where you are if you want, but thank you all so much, including Curiosity. And then I'd like to introduce our next guest. You have a really special speaker next, and that is Dr. John Holdren, who is the chief scientist, the top scientist. You know, like Top Gun? Well, he's the top gun in science in this country, the whole country. And he is the chief, not only chief scientist, but he's also my boss, so be nice to him. One of the things that's interesting about Dr. Holdren is he spent many, many years studying climate change and trying to change our behaviors to make the climate not change as fast as it is. So a lot of those climate change questions, maybe he'll answer some of them for you. The other thing that he's really special at is hiring people who look lots of different ways. We talked before about bias. He's probably the only person I've ever met in my life who doesn't have any bias. And I've studied bias, so I really know something about it. But Dr. Holdren is the fairest, kindest person and doesn't have prejudice against anyone because of what they are. All he cares is that they do a good job and they're smart. So with that, I'd like to introduce my boss, John Holdren.
Well, thank you very much, Joe, for that kind introduction. It's really a great pleasure to be here. I wish I could have been with you for the whole session. I had some other meetings, unfortunately, that I had to attend. But I'm really thrilled to be able to close this third ever SoSTEM event, the state of STEM in this country. Looking at the agenda, I can see that you have, in fact, heard from some really remarkable STEM role models today: computer scientists, engineers, park rangers, and of course, astronauts. You've also heard just now from a group of outstanding women who are not only at the forefront of their science and technology fields, but living proof that we all benefit when more girls and women pursue STEM studies and careers. And on the question of inclusion and opportunity in STEM, I want to offer one rather uplifting statistic. The Office of Science and Technology Policy in the White House, which I direct, has 125 employees in 5 divisions and the director's office. 4 of the 5 divisions are led by women in OSTP. You've heard from 2 of them, Joe Handelsman and Megan Smith. The chief of staff, who runs my office, is a woman. The chief counsel is a woman. The director of communications is a woman. The head of legislative affairs is a woman. We are a group, when the leadership of OSTP meets in our conference room, the men are generally outnumbered about 2 to 1. So again, another shining example that we all benefit when women and girls find inclusion and opportunity in the STEM fields. One thing the President made clear in his State of the Union address last night, which is really germane to what we're here talking about, is that science, technology, engineering, math, innovation are absolutely essential to our nation's future. If you think about it, our country's prosperity, our healthcare system, our environmental quality, our national security, were all built on the shoulders of STEM innovators. Many of them we've had here at the White House for a wide variety of events, including, in fact, the very chairs that you are sitting on have been occupied previously by Nobel laureates, by winners of national medals of science and of technology and innovation, of course, by high-tech CTOs, by astronauts. There's at least one being occupied by an astronaut right now that I can see, General Bolden. But in a sense, you are the most important audience of innovators who have filled these seats since the last time we assembled a bunch of STEM students here. And the reason is you represent the future of STEM in this country. As tomorrow's patent holders, tomorrow's problem solvers, tomorrow's app developers, tomorrow's expanders of the frontiers of science in all directions, you more than anybody are at the core of President Obama's vision for the future of this country. As the President has said, science, technology, and innovation are not just helpful, but they're absolutely essential to achieving every one of our nation's top goals, from growing the economy and creating jobs, protecting ourselves from natural and man-made disasters, creating an environment in which Americans can live longer, healthier lives, to addressing global challenges like climate change, the proliferation of weapons of mass destruction, and epidemic disease. And not to mention, of course, all kinds of super exciting stuff, like sending an American astronaut to space for 1 year for the first time. Astronaut Scott Kelly was celebrated last night in the State of the Union address and was in the First Lady's box. In late March, he will take off for a year in space. Extraordinary stuff. Discovering new potentially life-saving drugs, building prosthetic limbs that can be moved by thought alone. There are just so many extraordinary things happening in STEM to improve people's lives and to improve our understanding of who we are and the universe we live in. And we do really benefit from having a President of the United States who gets it in a way I think no president since Thomas Jefferson has gotten it in terms of the importance of science, technology, and innovation to everything we're trying to do. Just last year, President Obama became the first president, as far as I know, to write a line of code. And it was a middle schooler who taught him to do it in our Hour of Coding event here in the White House. Last year, he hosted the first ever White House Maker Fair, bringing some truly amazing gadgets to 1600 Pennsylvania Avenue. That included an 18-foot tall robotic giraffe that walked and talked. He also got scanned for the first ever three-dimensional printed presidential bust. Presidential bust produced by a 3D printer based on scans of 100 and some cameras looking at the president's head from all directions. That bust is now on display in the Smithsonian Institution and without doubt is the most realistic presidential bust ever created. He hosted TV meteorologists from all across the country to talk about climate science on the White House lawn. He has crisscrossed the country, and he's doing it today, meeting with entrepreneurs and innovators who are building apps, starting companies, turning bright ideas into products that improve people's lives. And of course, he is the first president ever to hold a White House science fair, and he's now held 4 of them. And on this topic, he's noted, as a society, we should be celebrating outstanding work in STEM by young people at least as much as we celebrate Super Bowl winners. He sometimes says to me, of course, I have to welcome a lot of great athletes to the White House, but I actually enjoy talking to scientists, engineers, and kids who are studying STEM even more. It's clear, then, that we have a president who gets it. We have a lot of good folks working inside and outside government, paving the way toward the new frontiers I've been talking about. But we're going to need the next generation. We're going to need you to keep up that momentum. We need you, your teachers, your supportive parents, your committed mentors to keep up the good work, the exciting work, the interesting work that has brought us all together today to celebrate and to talk about. You're the ones who are going to keep America innovating, making discoveries we can't even dream of today, finding solutions to some of the world's most important problems. So with that, let me just say thank you for all you've done, all you are doing, and for the extraordinary things that you will do in the future. Class dismissed.
All right, you heard it from the man himself. Thank you all so much for being here. We were so glad that you could make it. Thank you again to Dr. Holdren and Administrator Bolden. Let's give everyone a big, huge round of applause. Awesome. And thank you so much to our great panel. They were amazing. Hopefully, 3 cheers. Hopefully some of them can stay after and you can talk to them for a couple of minutes. But for everyone who's watching out there in their classrooms, thank you so much for joining us and have a great Big Block of Cheese Day.